This problem asks us to look at words. Now, a word is defined to be, for this problem, any string of 8 uppercase letters of the alphabet. So you could have 8 A's in a row, or A, B, C, D, E, F, G, H, or 8 Z's in a row. Those are all words. Repeated letters are allowed. So remember, there are 26 uppercase letters in the alphabet. Well, the first question is, how many words are there in total? Well, this is a permutation problem, so I usually like to draw a picture if it's not obvious. 8 letters, so I leave 8 blanks. Well, how many letters could this be? 26. How many letters could the next one be? 26, 26, 26, 26, 26, 26, 26. 1, 2, 3, 4, 5, 6, 7, 8. So it's 26 to the 8th power. All right, so how many of those words end with the letter X? Well, if you think about it, if it ends with an X, that's an X. It has to be. There's only one way we can define that character. It's an X. So the other the other 7 letters can be anything you want. So it'll be 26 times 26 all the way up to this one. So it's going to be 26 to the 7th power. You have no choice on that last one. If it ends with an X, you're told it must end with an X. All right, C, how many words begin with an A and end with either Y or Z? So we need to count up. I'm not going to draw 26 blanks here. I'm sorry, we're only talking about 8 letters. So A, that's 1, 2, 3, 4, 5, 6, 7, 8. We'll count up how many words look like this. Again, everything in between the A and the Y can be anything you want. And then we're going to have to add to it the number of words that look like this. 1, 2, 3, 4, 5, 6, 7. Oops. I need one more blank in there, sorry. Pretend like there are 6 blanks there in the middle. 1, 2, 3, 4, 5, 6 blanks with a Z on the end. So we just need to count these up and add them up. So 1, 2, 3, 4, 5, 6 letters can be anything you want them to be. The A has to be an A. There's only one way that can be there. If it has to end in a Y, there's only one way to do it. So we have 26 raised to the 6th power. That's the number that start with A and end with Y. We can also have start with A and end with Z, and we get 26 to the 6th power. And we're just going to add them together. That's it. So I'm just going to write this as 2 times 26 to the 6th power. All right, last one in this problem. How many words have exactly one letter from this set? So let's just think about what that means. If a word, in order to be only include one of these letters, if a word includes an A, it cannot have an M or a Y. If it has an M, it can't have an A or a Y. If it has a Y, it can't end with A or M. It can't contain an A or M. That's quite simple. Let's treat this like, first, let's take a look at how many words have exactly one letter from the set A. That means it has an A, at least one A, but none of these. All right, so we've got 1, 2, 3, 4, 5, 6, 7, 8. How many letters, how many choices do we have for this letter? Well, the alphabet has 26. We can use an A, but we can't use these two. So it's going to give us a 24. 24. All the way. I'm going to write this really messily. That's how many words contain A and no M and no Y. So now we have to add that to the number of words that have an M but no A. And it's going to be exactly the same thing. If it's got an M, you have to leave out A and you have to leave out Y. So that gives us 24. It gives us the same thing. And then we repeat that the third time. 24 times 24. So this would be 24 choices to the 8th power. That would be 24 to the 8th, and that would be 24 to the 8th, and you simply add them together. 3 times 24 to the 8th power.